a to the power of 1 equals a, then log a to the base a equals 1. The logarithm of any number to the base of the same number is equal to 1. We can just add or subtract the logarithms only when the bases are same. Otherwise, we cannot do any mathematical operation on the logarithms. Antilog of 1.563 is 36.56. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to the session. In this session, we will be discussing about logarithms, which is the unit 3, and this will be the first session on logarithms. So let us see what we mean by logarithms. So in the introduction, if a is a positive real number other than 1 and y equals a to the power of x, then x is called the logarithm of y to the base a, and it is denoted by x equals log y to the base a. So here we need a positive real number. So if a is a positive real number other than 1 and y is equal to a to the power of x, then we can say that x equals log y to the base a. So if a is any non-zero real number and a to the power of 0 equals 1, then log 1 to the base a equals 0. That is, the logarithm of 1 to any base is 0. If a is any non-zero real number, then a to the power of 1 equals a, then log a to the base a equals 1. The logarithm of any number to the base of the same number is equal to 1. So let us understand the laws of logarithms. So here we have log of mn. Log mn to the base a equals log m to the base a plus log n to the base a. So we can, whenever there is m into n, we can add the logs of these values. Then log m by n to the base a, that is log m by n to the base a equals log m to the base a minus log n to the base a. So suppose I have log m to the power of n to the base a. So this will be n log m to the base a. Now this is the change of base rule. So log n to the base a equals log n to the base b to the log a to the base b. That is, we can just add or subtract the logarithms only when the bases are same. Otherwise, we cannot do any mathematical operation on the logarithms. So log a to the base b equals 1 by log b to the base a, and log a to the base b equals log a by log b. So these are the various laws of logarithms. Now express the following in logarithmic form. So when we have to express this, I will write it as log 32 to the base 2 equals 5. So whatever is the power, it will be the equated here when you assume the log. So here, suppose I write here log of 1 by 9 to the base 3 equals minus 2. Here, log of 0.04 to the base 5 equals minus 2. Next, express the following in exponential form. See, we can see here 81 is nothing but 9 square. So I will write it as 9 square equals 81. Now here 10 to the power of minus 2 equals 0.01. 2 to the power of minus 2 equals 1 by 4. Now solve for x. Now we have log of root 32 to the base 2 equals x. Now, if I write it in exponential form, it will be 2 to the power of x equals root of 32. 2 to the power of x equals 32 to the power half. So, x will be equal to half. That is the answer. Right? Next one. Here, 0.1 to the power x equals 10 or 0.1 to the power x. So it will be, you have to express it in 0.1. So when we express this 10 in terms of 0.1, we get the power of 10. So 0.1 into how many times I have to multiply 0.1, 0.1, 0.1. So that many times I have to multiply in order to find the value of x. So 0.1 into 0.1, 0.1 into 0.1 is 1, 1 into 0 is 0. So again into 0.1, so you have to keep on multiplying. So 0.1 to the power x equals 0.1 to the power 10. So x equals 10 is the answer. Now, here we have cube root of 5 to the power 6 equals x, or I can write it as 5 to the power of 1 by 3 whole to the power of 6 equals x, or I can write it as 5 to the power of 6 by 3 equals x, or 5 to the power of 2 equals x, or 25 equals x. That is the answer. Now, x to the power of 4 equals 625. Now, I will have to factorize this 625. It is divisible by 5. 5 ones are, 5 twos are, 5 fives are. 5 twos are, 5 fives are. 5 fives are, 5 ones are. So you can see it is 5 to the power of 4. X to the power of 4 equals 5 to the power 4. When the powers are same, the bases are equal. Therefore, x equals 5 is the answer. Now, using logarithmic table, find the logarithm of each of the following numbers. See, now we have to find the log values of these numbers. So first thing is we have to count the number of digits to the left of the decimal sign. So where they have here 3 digits, so 3 minus 1, I write it as 2. Then I take the log value 563.5. So first thing is I will have to check in the log table 56 and under 3. So 5, 6 and under 3 it is 7505 plus under 5 it is 4. 7509. So it is 7509. So the log value of 563.5 is 2.7509. Now suppose it is the log value of 12. So how many digits are there? 2 digits. 2 minus 1 is 1. 1 point. Now I will write the value given in the table. So if you can see here 12, 0792. So this is the log value of 12. The next one, the log value of 0.0057 here. So the log value is to the left of the decimal sign is 1, and after that again 2 decimal signs we have. Totally I'll write it as 3 bar equals 3 bar into, then I will see the number 57. So 57 means 7599. So this is the value of this number. Then Here you can see here 1, 2, 3. So 3 bar plus 1, 4 bar point. So whenever there is more zeros, we have this. We count the number of zeros and add a minus sign above that. So we call it as 4 bar. Then we write the value of 63. So the value of 63 corresponds to 7993. That is the answer. Then using logarithm table, find the anti-logarithm of each of the following. Now this is already the log value given in the problem. Now we have to find the anti-log of this. So how do we find the anti-log? So for the anti-logarithm, we will see the value from 0.563. So from 0.563, we take the value here. So from the log table, 0.563, it comes up to 3656. So 3656. Then we have this point there. So if there is 1 point, that means 1 plus 1, 2. So after 2 points, I write the decimal. So the anti-log value, anti-log of 1.563 is 36.56. The next one is 0.643. So 0.643. So from 0.643, I'll find out the value. 0.643, it comes up to 4395. Right? So here there is 0. 0 plus 1 is 1. So I write the decimal 4.395. So anti-log of 0.643 equals 4.395. The next one is 3 bar 0.673. So we will have to take the value from 0.673. So from 0.673, 4710. So we got the value as 4710. Now there is 3 bar. 3 bar means point. So there are minus 3. So minus 3 plus 1 will be minus 2. So when there is minus 3, we add 3 zeros here. We add 3 zeros. And after the first 0, I put a decimal. So this will be the anti-log value. Now, here we have this 0.078. So we have to find the anti-log of 0.078. Now from here I'll take, after the decimal point, 0.07. So I take the value as 0.078. Now anti-log of 0.078, I take the value as 0.07. So 0.078, 1197. So this is the what the table is telling, 1197. Now after the decimal, before this decimal point, we have this 0.0. So we add 0 plus 1 is 1. So I write it as 1.197. Next, find the value of root of 9 by 4 minus log of 3 by 2. Now this I can write as log of 9 by 4 to the power half minus log 3 by 2. Now I have this problem, log of root 9 by 4 minus log of 3 by 2. Log of 9 by 4 whole to the power half minus log of 3 by 2. So this will be equal to log of 9 by 4 to the power half, and if there is a minus sign, we take the reciprocal into 2 by 3. Or this can be expressed as root of 9 is 3, root of 4 is 2. Log of 3 by 2 into 2 by 3. 2 and 2 cancel. So log 1 is the answer. The next one, prove that log 7 by 8 plus log 32 by 49 minus log 4 by 14 equals log 2. So I can write it as log of 7 by 8 into 32 by 49 into 14 by 4 equals log 2. So when there is addition of logs, I can multiply, and when there is a minus, I can just multiply the reciprocal of that. So it will be 8 4s are 32, 7 7s are 49, 7 2s are 14. So here it will be 4 and 4 gets cancelled. So I am left with log 2 equals log 2. That is the answer. The next one, prove that 2 log 3 by 5 plus 3 log 5 by 2 minus log 45 by 8 equals 0. So this I can write it as log of 3 by 5 the whole square plus log of 5 by 2 the whole cube minus log 45 by 8 equals 0. I can rewrite it as log of 3 square 9 by 25 into 5 cube. 5 cube means 5 5s are 25, 25 into 5, 125, 2 cube. 2 2s are 4, 4 2s are 8 into 8 by 45. Now, when I simplify this, 8 and 8 gets cancelled. 25 into 4s are 25, 5s are 125. Then 5 9s are 45. 9 and 9 gets cancelled. So the answer is 0. So there are no numbers here. So the answer is 0. The next one, prove that log 12 by 15 plus 2 log 6 by 8 plus 1/3 log 8 by 27 equals log 3 by 10. Now, I'll rewrite it as log 12 by 15 into log 6 by 8 the whole square plus log 8 by 27 to the power of 1 by 3 equals log 3 by 10. Now, this will be equal to log 12 by 15 into 6 square. So, 6 square will be 36 by 8 8s are 64 into, so cube root of 8 is 2, cube root of 27 is 3. So, it will be log of 3 by 10. Now, I simplify this. So, it will be equal to 2 3s are 2 2s are. So, here 2 6s are 12, 2 1s are 2 6s are. Again, when I simplify this further, I'll get it as 3 2s are, then 2 8s are, then again when I further simplify it, I get it as log of 3 by 10 is the answer. The next one, prove that root of log a by b plus root of log b by c plus root of log c by a equals 0. So this can be written as log a by b to the power half plus log b by c to the power half plus log c by a to the power half equals 0. Now I'll write it as log of half into a by b into b by c into c by a. A gets cancelled. So log of half into 0 equals 0. That is the answer. So with this, we come to the end of this session. Hope you have all followed it. Thank you.